All right, so we're going to be looking at equivalent statements and variations of conditional statements. Equivalent. An equivalent compound statement or statements are made up of the same simple statements and have the same corresponding truth values for all true-false combinations of these simple statements. Now, two statements are equivalent, and we use, in logic, we use the equivalent symbol, where instead of in algebra, we use for equivalency an equal sign with 2 lines, but in logic, we're using 3. It says, if they have the same truth value in every possible case. So example 1, it says, show that P or Q and not P, or if not P, then if not Q, then P are equivalent. Use the results from part A to write a statement that is equivalent to, I attend classes or I lose my scholarship. So let's look at the first part here. It says show that P and Q, and so let's look at P or Q, not say and, but P or Q. We're going to show that first by table form, a truth table. So for or, at least one must be true. Okay. And then we're going to show, if not Q, then P. So we're going to write, construct our table. Not Q. Excuse me, let's do Q first. Now, not Q. We have false, true, false, true. Then if you want to write P again, you can, just for the sake of order. So if not Q, then P. And what do we have here? We're saying that in order for our statement to be false, the antecedent, the first part of if must be true, the second part, consequence, must be false, then the whole thing is false. And we do have a TF, therefore the remaining is true. So we've shown that P or Q and if not Q, then P, they are equivalent. Now it says here, use the result from part A to write a statement that is equivalent to I attend classes or I lose my scholarship. Well, here's part B. if I do not lose my scholarship, then I attend classes. There we go. Example 2. It says here we want to show that not, then we have not and not P, is equivalent to not P. Okay? So whenever we see, this is what we called a double negation. This is a double negation. The double negation of a statement is equivalent to the statement. So we're going to show that we have several double negations here that it's going to be equivalent to not P. So we're going to construct a truth table. We're going to start off with P. And we can just say true, false. We don't have to go true, true, false, false, because either it's going to be true or it's going to be false. So starting from the inner portion of the bracket here, not P, we're saying false, true. Then we're negating that not P. That's true, false. And then we're negating that part. And then we're saying false, true. Therefore, they are equal. We have an equivalent statement. All right, last example on this page here. It says, select a statement that is not equivalent to. We have here, if it is raining, then I need a jacket. So we have 4 different statements. Part A, it's not raining or I need a jacket. Part B, I need a jacket or it is not raining. Part C, if I need a jacket, then it's raining. And last part D, if I do not need a jacket, then it's not raining. So let's set up our simple statements. For P, it's raining. For Q, I need a jacket. And let's look at each statement that we have here. Part A, it's not raining or I need a jacket. How would we write this out? We would say not P, or we see our connector or, and we have Q, and then we have a negation. So we're going to construct a truth table with this. We'll do this in parts. So for P, true, true, false, false. We have 4 cases here, and then for Q we have true, false, true, false. All right, so what's given, initially what's given here, it says, if it's raining, then I need a jacket. Let's look at that part. How do we write this out with our connectives? Okay? Is it a conditional or is it a biconditional? It's a conditional. If then. Okay? So, we can first, let's start with that, and then we'll go with A. So, which one would be false? Okay, our second statement. If T then F, it would be false. So, the remaining is all true. Now, let's look at part A. If not P or Q. Well, let's write not P first. So that would be false, false, true, true. And then we can go ahead and finish this out here. Or not P or Q. At least one must be true. So then we're going to have here true, false, true, true. So far, part A is equivalent to it's raining. If it is raining, then I need a jacket. Notice that the truth tables, the values are the same. Let's look at part B. It says I need a jacket or it's not raining. So we would say Q or not P. And we have not P, we have Q. Here again, at least one must be true. P or Q. So we have here T or F, that's going to be true. We have F and F, that's going to be false. Then we have T and T, we have true. We have F and T, that's true. So far, that is equivalent to the original question, example A as well. Let's look at C. C has, if I need a jacket, then it's raining. We have a conditional. Using our connective here. If then. This is example C. So, the antecedent must be true. The consequence must be false for it to be false. So, therefore, we have TF, that's true. We have FT, that is true. We have PF, that is false. And then we have FF, that is true. So far, what's not equivalent at this moment, because if you look at the original question, statement A and statement B, they are all equivalent, but statement C is not. Let's finish the last example, D. If I do not need a jacket, then it's not raining. So we're saying not Q. If not Q, then not P. And here we go. So not Q and not P. And if we want to draw a not Q, we can go ahead and do that. We know not Q would be false, true, false, true. So not Q and not P. So we have here FF, so that's going to be true. Then we have TF, that's going to be false. Then we have FT, true. And then we have T and T, that's true. So This last statement, if I do not need a jacket, then it's not raining, is equivalent to statements B, A, and the original question. Therefore, which statement is not equivalent? That is letter C.